What's up, scholars? Today we are going to do a little chapter 1 review. So go ahead and get out your notebooks, get yourself a new space. Chapter 1 review. Chapter 1 was all about the building blocks of geometry. The building blocks of geometry. So, we had the point, the line, and the plane. The point is the simplest one. It's just a point. Has no dimension. It's a single spot in time. And we talk about it, refer to these points with just a letter. Like this could be A. It has no symbol. We just assume one letter by itself is just a point. A dimensionless space and time. Then we have a line, which we get when we put infinitely many points together, starting from a point and then continuing on in both directions forever and ever and ever. There's our line. Now, to talk about a line, we really need 2 points on the line, so it tells us where it is and where it's going, right? We need some location and direction. So we could call this line BC. It goes through point B and point C. It also goes through infinitely many other points, so it actually has infinitely many other names as well. But for simplicity, we're just going to call it line BC. Which when we speak about it in symbols, are the 2 points in question and a line on top of it. Cool. And finally, our plane is one more step up. We've got a point, and then we make an infinitely many more of them in a line going that direction. And then we make another line going in another direction everywhere. And the plane is all this area that we mark out. All these points that go with those lines that went in 2 directions. Oh yeah. It's a flat surface. And to talk about a plane, we need 3 points. 3 points that are not in one straight line. Because otherwise, those 3 points could just be a line. They wouldn't be a plane also. Hey, look at that! Not a plane. That's a 4-dimensional object. In space and in time. This is just a plane, though. It's got 3 points that are not all in one straight line. Because then it wouldn't define a plane. It would just define a line. 3 points that are not in a line. Let's call them D and E and F. So we'll call this plane DEF, which you could just name with those 3 letters. You can also use this plane symbol, DEF. Either one of those are okay. There's your point, and your line, and your plane. A point has no symbol that goes with it. It's just a letter. A line has 2 points that are on that line and a line symbol on top of it. And then we've got this plane, which is a flat surface that is defined by 3 points that are not all in one straight line. And a plane can be written just as those 3 letters, or with the plane symbol and then those 3 letters. Fabulous. Point and line and plane. That's how we're going to base, that's what we're going to base everything in this course about. Those points and lines and planes. Cool. Real fun happens when we start combining these things together, points and lines and planes. Like, what if we combined a point and part of a line? So our line doesn't actually go forever in both directions anymore. It just goes forever in one direction. What's that called? That, my friends, is a ray. A ray also needs 2 points to be described. It needs that starting point and then literally any other points on the ray, since it goes through infinitely many points. You want, where's it start and where's it going? Well, let's call this guy G, H, since we've already used all the rest of the letters. So to talk about an array, we need 2 points. We need starting point and where it's going. We write the starting point first, and then we say where it's going. It's good to know where you are before you start moving. And then our symbol goes from where it starts to where it's going with array. Cool. What if we combine 2 rays together? So we've got a point, and then half of a line, and then, you know what, let's just reuse that same initial point and put another ray on there. What do we make? We make an angle. Oh yeah. Now sometimes we can just talk about this angle just by the point where it starts. If there's nobody else around, then the point where it starts is the only thing I need to use to talk about it, because there's no other angle thing here. So this could be, let's call it letter I, angle I, which will have a nice little angle symbol before the letter. Or maybe it's around some other angles that also have this point I in them, so we need to distinguish it, so we use 3 letters to talk about this angle. So we're still going to keep that one, obviously, that's important. And then we need another point on that ray, and another point on that ray. Let's call that one J and K. So this exact same angle I might also be called angle J, I, K. Cool. What if we now put another angle right next to that angle? Yeah, let's do that. Let's use that same point. And you know what? Let's just even use this whole same ray. Let's just make an angle using a lot of what we already have. We're math magicians. Trying to write as little as possible. We'll just reuse what we have. So then I made another angle here. J, I, J, K, L. Now we have 2 angles. We had this one angle, J, I, K, that was here. From J to I to K. We made another angle that also uses that point I, that goes from L to I to J, and it's not the same size. So we name this as angle LIJ. Oh, we've actually made another angle by doing that we didn't even try to. We made a big angle. Angle LIK. Because if we add Lij to Jik, we make a big angle. Angle LIK. So we could measure all of these guys, figure out how big each of them are. We're not going to, but we could. Also right here, we just wrote out what's called the segment addition postulate. Let's get a pretty fancy color for that one. The segment addition postulate. That's also another kind of building block of geometry. Adding those two guys together. Awesome. So we have points and lines and planes and rays and angles that are right next to each other that we can add up to make bigger angles. There are really special things that happen with angles that are together. Another example of angles that are together are these angles that are made when you take two lines. Right, take two lines, draw them across from each other. How many angles did we just make? We made 4 angles. We've got an angle right here. 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 Four angles. But actually, if we measured these angles, the angles that are directly across from each other would be equal to each other. These angles would be equal to each other. These angles would be equal to each other. Those are a special pair of angles called a linear pair. Haha, just kidding. Everyone calls them a linear pair, but they're actually a vertical pair. A linear pair is something related that we could see in the same picture, but not what I just described. Those are called a vertical pair. Here's a real linear pair. Two angles that are right next to each other that together make a straight line. That's a real linear pair. Angle 1 and angle 2 together make a straight line. And we know straight lines have 180 degrees. Now actually, if we go back to these vertical pair examples, which are the angles that are congruent to each other, that are across from each other when two lines cross, there are a bunch of linear pairs in this picture too. Any two angles that together make a straight line are a linear pair. So angle, call that one 3 and 4 and 5 and 6. There are 1, 2, 3, 4 pairs of linear pairs from this picture. There are 2 pairs of vertical pairs from this picture. Pretty cool stuff, huh? Yeah. Geometry is the bomb. There's 2 other special kind of angle pair relationships that we're interested in. Angles that add up to things that are interesting, like lines and half of lines, like perfect corners. So let's check those out real quick. angles that add up to a right angle. Those are interesting. Right angles are really pleasant. So if you could have two angles that add up to a right angle, yeah, we're here for that. Could have two angles that add up to a right angle. That's all you need to be a complementary angle. Two angles that add to be a right angle. Or two angles that add up to be a straight line as far as degrees are concerned. Like, let's say that's 30 degrees and that's 150 degrees. Those two angles together make 180 degrees, which is the same as a straight line, which makes those two angles interesting to us. And that interesting to us has a name called supplementary. Now I drew this on purpose. These two angles were next to each other. These two angles were not next to each other. It could have been the other way around. These two angles could have been not next to each other, and these two angles could have been next to each other. To be complementary, you just have to add to 90. You can be far away. To be supplementary, you just have to add to 180. You could be far away. Or you could be right next to each other. It's your choice. You're complementary. Guys, I just realized this was supposed to be the angle addition postulate. I was yawning all and on about the segment addition postulate, and these are angles that I added up together. Whoa. Which leads me to my next point. Secret video bonus question. For 5 points, what is the segment addition postulate? Draw an example and use actual numbers to demonstrate. Secret video bonus question. Alright, scholars. Love ya. I'll see you next time. You know, good things come to those who hustle, so keep on that hustle.